Crystal field theory applied to octahedral complex. The octahedral complex of six lesions symmetrically arranged around a central atom, defining the vertices of octahedron. When the six lesions approach towards the metal center, the electrons in the orbitals of the metal are repelled by negative point charge of the lesions, which ultimately rise the energy level of all d orbitals, excited state d orbitals. Among 5 d orbitals, not all d orbitals which interact to the same extent with the 6-point charges located on the three-dimensional axis. This is because the lobes of two orbitals dx square y square and dz square called EG sets lie directly in the path of approaching the lesions. The electrons in these orbitals experience greater force repulsion and hence the energy of EG orbitals is increased, whereas the lobes of three orbitals dxy, dyz and dxz called T to Z sets, dxy, dxz and dyz called T to Z set are directed in space between the part of the approaching lesions which experience lower force of repulsion and hence the energy of T to Z orbital is decreased. In this way, the 5 degenerate d orbitals in the metal cation split into two separate energy levels. This separation of the 5 degenerate orbitals of metal ion under the influence of approaching lesions into the two sets T2Z and EZ having the different energies called as crystal field splitting. Octahedral splitting of d orbitals in the octahedral complex, EZ orbitals and T2Z orbitals. EZ orbitals are stabilized by plus 0.6 and T2Z orbitals are destabilized by minus 0.4. So equal EG and T2Z orbitals. We can write also in this way, also this way. You have to remember only one is sufficient. Where delta naught R dq is splitting energy called crystal field stabilization energy, extent to which the 5 degenerate orbitals separated into the two sets levels and the energy gap between T to Z EZ sets can be denoted by delta naught or dq, 10 dq, called as crystal field splitting of the d orbitals in the octahedral field does not alter the average energy of the 5 d orbitals. For an octahedral complex, an electron in the more stable T to Z set is treated as contributing to a stabilization of minus 2 over 5 delta naught minus 0.4 delta naught. Whereas an electron is higher energy, EZ sets contributes to the destabilization of plus 3 by 5 delta naught 0.6 delta naught, so that the total increase in energy of 4 electrons in EZ set is equal to total decrease in energy of 6 electrons in T to Z sets. Okay. It's all about crystal field theory applied to octahedral complex. Thanks for watching and request you all like, comment, share and subscribe. Thank you for patience. That is now. Bye-bye. See you again.